Hi, this is Mr. Maryland. We're looking at number 24 on homework 6. So, we have a cat burglar on a string here, and because we're in the middle part of the string, we're actually looking at two tensions. So I've halfway completed my force diagram here. We have positive x and positive y. Again, no reason to tilt the axis. One sticking point you might have is, okay, this angle here is 36 degrees. That doesn't do us much good in terms of what we're used to looking at. Of course, you could solve it from that perspective, but we're used to looking at angles uh, near the axis like that. So I recognize that if this is 36 degrees, this must be 36 degrees. Maybe it's easier for you to recognize that there's a right triangle here, and that if this is 36 degrees, then this angle here must be 54 degrees. You could really do either way, you'll get the same answer in the end. Okay, the other thing we have to do now is draw the components. So I'm going to draw the horizontal component of FT2 and the vertical component of FT2, and then we can get to the point where we list our forces. But before we do that, we should note that this must be congruent to this. They're the only two forces on the y-axis, and that this must be congruent to this for everything to balance out. Okay, so, and we could also label these if we wanted. This would be FT2y, this would be FT2x. We go down here and say, okay, the force of gravity is 0, there's no x component. Now you might be tempted to say negative mg, but remember, it's not giving us a mass here. It's telling us that the weight or the gravitational force acting on this cat burglar is 675 newtons. Of course, you could find the mass and plug it back in, but like I've said before, if it gives you the weight, you can just write that rather than mg. But typically, if it gives you the mass, you want to write mg. And this will be a negative because it's going down. And then we have the first tension here. That is completely horizontal, so this is going to be negative ft1, comma 0. There's no y component. And then for the second tension, it's going to be positive ft2 cosine of 36, because the x is the adjacent component, comma ft2 sine of 36. Okay, those are a list of our components. From those list of our components, we can generate two equations. From the x components, setting equal to 0, we know that negative ft1 must equal ft2 cosine of 36 degrees. Oh, sorry, I don't know what I'm doing here. This positive equals 0. So those two added together equals 0. I don't know why I wrote a equal sign there. And then the sum of the y components set equal to 0, that'll be negative fg plus ft2 sine 36 degrees equals 0. Okay, now we're at the point where we can actually find out what we want. What do we want? It says the tension in the inclined cable. Well, T2 is the inclined cable, so we want FT2. We see that right here. We see that right here. So it'd be really easy to get it by looking at this equation, right? Because if we try to get it from this equation, we run into the issue of we don't know what FT1 is. But if we use this equation that was generated by the y components, then it's just a matter of rearranging. Right? Fg equals ft ft2 sine 36 degrees just by taking this equation here and throwing this on the other side. And then one more step to divide. And we find ft2 is the weight, so in my example it's 675 newtons, you likely have a different number, and then divided by the angle, which you'll likely have a different angle, but very easy once you solve that out. Alright, so just email me if you have any questions.